Hi class, now that we've covered the forecasting section, let's take a look at a couple of examples using the moving average method, weighted moving average method, and exponential smoothing. The following table gives the number of orders that Professor Bate receives each week for his latest college textbook on using statistics to make business decisions. You see we have a table of the weeks and the orders received. Forecast the demand for the week of October 12th using a 3-week moving average. So using the data, historical data that we have, using a very basic 3-week moving average, we would take the last 3 weeks of orders, which gives us our solution. We take 381, 368, 374 divided by 3, which gives us around 374 orders for our October 12th prediction. Using a 3-week weighted moving average with weights of 0.1, 0.3, and 0.6, using 0.6 for the most recent week because we want to give the most recent week the most weight and the most impact in our algorithm, forecast demand for the week of October 12th. Using the weighted moving average, we multiply the weight by the orders for the last 3 weeks accordingly. Weighted average for 9/21 is 0.1 times 381, and I'm using 0.1 because I said that these are the weights I'm assigning, with the highest 0.6 being for the most recent week and then going down. So for 9/21 we get 38.1. Weighted average for 9/28 is 368 times 0.3 is 110. Weighted average for 10/5 is 374 times 0.6 is 224.4. So we tally these up and we get around 373 for our forecast for October 12th. Compute the forecast for the week of October 12th using exponential smoothing with a forecast for October 31st of 360 and a weight or smoothing constants of 0.2. In our problems, the smoothing constant will be given to you. If you're wondering where this number came from, you don't have to find it. It will be given to you. So for August 31st, we're told in our problem that we will start with 360 orders and our forecast is 360 orders. We're using these numbers from our original problem and we're told that our forecast for October 31st is 360. We need that to be able to solve this problem. So we simply take our actual orders minus our forecast, which gives us our error. In this case, we had 0 error. We take our error and we multiply it by our smoothing constant of 0.2. In this case, 0 times 0.2 is 0. We take whatever this number is and we drag it down and add it to our next forecast. Well, in this case, 0 plus our previous forecast of 360 gives us another forecast of 360. But we had 389 actual orders on that date. So we take that minus 360 gives us 29. Multiply 29 by our smoothing constant. 29 times 0.2 gives us 5.8. So we take 5.8 and we drag that down and we add 5.8 to our previous forecast, which gives us our new forecast of 36.5.8. And we take the difference of the actual orders and we get 44.2. We multiply that by the smoothing constant and so forth. I'll give you a second to look at how this is done.